For problem number 12, we have two modes of depreciation used to depreciate the original cost of a car after T years. So in method 1, the car loses 20% of its current value each year, giving the formula V equals C times 0.8 to the T power. Method 2, the car loses $2,000 in value each year. This would be a linear function, V equals C minus 2,000 T. So for a car that originally costs $20,000, that's going to be your C value. So C is equal to $20,000. Now, how might we know that? Well, at the time when T is equal to 0, if you plug 0 into the first calculation, you would get V equals C times 0.8 to the 0 power, and 0.8 to the 0 power is 1. So the value of the car at time T equals 0 would be C. In the second equation, again, when T is equal to 0, you're going to get V is equal to C minus 2,000 times 0, and 2,000 times 0 is 0, so V would be equal to C again. So C is the original cost of the car, and from the last statement we know that C is equal to 20,000. So what we would have here then is we're looking for after approximately how many years will the value be the same under both methods. And to do that, we simply have two equations here. 20,000 times 0.8 to the T power, and that has to equal 20,000 minus, that would be 20,000, that's correct, I said it right, 20,000 minus 2,000 T. So to do this, we're going to bring in the graphing calculator and set up the two different equations using x instead of t. And so we start off with the exponential function, 20,000 times 0.8 to the x, and 20,000 minus 2,000x. And let's set up our window. We know that, well, I'm going to assume that this will happen within 10 years. You could go from 0 to 20 if you wanted. I go from 0 to 10 by 1 year. And the y values, the maximum value is 20,000. Since it's going to depreciate, it'll only be less than that. So the y values will be from 0 to 20,000. And we can go up by 1,000. And that should be good enough. We go to graph it, and we can see that they will have the same value at the point of intersection down here in the lower right hand corner. So to find that, we're going to hit second trace number 5 for intersect. That's the first curve, that's the second curve, and we just move a little bit closer to the place where the intersection occurs and hit enter for guess, and we end up with 8.499, and that is roughly at 8.5 years. So the answer C would be the optimal answer here for 8.5 years. Alright, so that does it for this problem number 12.